Elementary Stats, Unit 1, Lesson 11, Compound Events. In this lesson, we're going to find the probability of mutually exclusive events, and we're going to find the probability of inclusive events. So a simple event is something that describes one single outcome, like flipping a coin. A compound event is made up of two or more simple events, flipping a coin and rolling a dice, or flipping a coin twice. A mutually exclusive event is two things that both cannot occur at the same time in the trial of an experiment. So flipping a coin and having it land on heads and tails in the same flip is mutually exclusive. Rolling a 1 and a 2 on the same roll on a dice is mutually exclusive. So the mutually exclusive events both cannot happen at the same time. So this, if we have mutually exclusive events, then we can add them, but we can't multiply them. So if it was the probability of A and B occurring, that's mutually exclusive. It's impossible, but we could say what's the probability of A or B occurring, and this is the union symbol. What's the probability of A or B happening? We would add those together. So when you have an OR probability, you're going to add them together, and that's what we've got right here in the example. A group of students is donating blood during a blood drive. A student has a 9 out of 20 probability of having type O blood and a 2/5 probability of having type A blood. Explain why the events type O and type A blood are mutually exclusive. They are mutually exclusive because you can only have one blood type. You either have type O or type A, but not both. Now, since they are mutually exclusive, we can find the probability of having one or the other. So the probability of having type O blood is 9 out of 20. Or, so or means add, what's the probability of having type A? Type A is a 2 out of 5 probability. So we can add those up. We can either type them in a calculator or we can add them up by finding a common denominator. So 9 out of 20 plus 8 out of 20 is 17 out of 20. If you type that in a calculator, you might have gotten 85% or 0.85. So any of these three answers will work, either 17 over 20, 0.85, or 85%. Explain why the events voted for Hunt, voted for Klein, and voted for Vila are mutually exclusive. You only get one vote. You can't vote for three people. In this situation, each student casts one vote for senior class president. Of the students, 25% voted for Hunt, 20% for Klein, and 55% for Vila. A student from the senior class is selected at random. So you can only, if a student from the senior class is selected at random, they would only have one of the three votes, not all three. Find the probability that one student voted for Klein or Vila. So the probability that someone voted for Klein is 20%, and the probability that someone voted for Vila is 55%. So we would have 20% or, which means add 55% for Vila. So there's a total of a 75% chance that someone voted for either Klein or Vila. An inclusive event is where we have to find the probability of the first thing, find the probability of the second thing, and we have to subtract the things they have in common. So this could be thought of as the doubles or something that's counted twice. So if you had the probability of rolling an even or a prime number, we would take the probability of finding an even number, find the probability of a prime number, and then subtract the doubles. So we would put these two words together. We would subtract the even primes. So the probability of an even number is there are 5 numbers total, so we would have 3 out of 5. Or prime numbers, there are 3 prime numbers. Subtract, the doubles are going to be in the middle of our Venn diagram here, so there is 1 out of the 5 that's been counted twice. Add these up, there is a 5 out of 5 probability that we are going to select an even or a prime number. If we didn't subtract the doubles, we would end up with 6 out of 5, and you can't have a probability greater than 100%. So here's the summary of what we just talked about. Find the probability of A or B, and then subtract the doubles. Subtract the A and B. So what's the probability on a dice of rolling an even number or a 4? So we have 1, 2, 3, 4, 5, 6. The probability of rolling a 4, there is 1 out of the 4. The probability of an even number, there are 1, 2, 3 even numbers. We have to subtract the even 4s. So there is 1 even 4. So the probability here is, I wrote the bottom denominator. There's 6 possibilities here. So there's 1 4 out of the 6, and we're going to subtract the 1 even 4. So this would be 1/2 or 50%. Find the probability on a number cube of rolling an odd number or a number greater than 2. So there are 1, 2, 3 odd numbers out of the 6, or a number greater than 2. There are 1, 2, 3, 4 numbers greater than 2 out of the 6, and we have to subtract the odd numbers that are greater than 6. So the odd, or excuse me, greater than 2. The odd numbers greater than 2 are, there is 3 and 5. There are 2 of them. So our probability here is 5 out of 6. Remember, in a deck of cards, there are 4 suits. Each suit has 13, so there are 13 hearts. There are 52 in the deck total. There are 4 aces, 4 kings, 4 queens, etc. So in this case, what's the probability of drawing a king? That would be, there are 4 kings out of the 52 cards. Or means we're going to add the probability of a heart. There are 13 out of the 52 hearts. And then we have to subtract the king of hearts. There is 1 king of hearts. So this probability would be 16 out of 52, which we can simplify down to be 4 out of 13. There's a 4 out of 13 possibility of drawing a king or a heart out of the deck of cards. What's the probability of drawing a red card? So there are 13 hearts, 13 diamonds for a total of 26. So there's your probability of a red card. There are 4 jacks, 4 queens, 4 kings for a total of 12. So there's 12 out of the 52. And then we have to subtract the red face cards. So there are 2 of these, 2 of these, 2 of these for a total of 6 cards that have been counted twice. So now we're going to use a Venn diagram to do the same thing. We have to figure out the probability that a student was a senior or read a daily paper. So we're going to find the probability that someone was a senior, and then we're going to add it to the probability that they read a daily paper, and then we're going to subtract the doubles. We're going to subtract the senior paper readers. So there are 1,560 students that were surveyed. 840 were seniors, and 630 read a daily paper. So we can start off by saying 840 out of the 1,560 seniors, and then it says or they read a paper. So 840 seniors, 630 read a paper. So there's our second probability. 630 out of the 1,560 read a paper, and then we have to subtract the doubles, and we can find the doubles from setting up a Venn diagram. It says only 215 of the paper readers were juniors, so the 630 minus 215 will give you the senior paper readers. Right, so 215 juniors, 630 minus 215 is 415. And that's the number that we're going to subtract in our probability. So this is the finishing what we started on the first page. 840 seniors out of the 1,560 total. 630 paper readers out of the 1,560 total. Subtract the senior paper readers, that's 415. And then simplify that to be the fraction's fine, or 67.6% is fine as well. Of 160 beauty spa customers, 96 had a hairstyling and 61 had a manicure. There were 28 customers who only had a manicure. What is the probability that a customer had a hairstyling or a manicure? So we have to find the probability. So we want to know hairstyling or a manicure. So the probability of hairstyling would be 96 out of the 160. And then it says or had a manicure. There were 61 had a manicure. And then we have to subtract those who had a style and a manicure. So it said there were 28 customers who only had a manicure. So the 61 minus 28 will give us 33. So if we look at our Venn diagram, 28 had a manicure. The 61 minus 28 is 33. That's our overlapping piece right there. So we take everybody who had a hairstyling, everybody who had a manicure, and we subtract the numbers that were counted twice. And that's the middle of the Venn diagram. So you can see that right here. Add those together, simplify either 31 out of 40 or 77.5%.